gave this talk in Belcat Europe in London last autumn. I would like today to give you a kind of summary of what we did. So the talk was related to a new technology that we built inside Trend to be able to cope with the limitation of technology like signature-based detection or anomaly-based detection. So why we think that the traditional malware detection technique are becoming more and more obsolete is because modern and current threats are very technologically advanced. For example, they use like polymorphism, code obfuscation, a lot of our techniques that makes traditional system very difficult and less efficient. Another problem we are facing is that there are a lot of new threats that are emerging every day, and then traditional techniques, they are time consuming. So both like static and dynamic techniques, they are very slow and they should process each file or each URL one by one, which takes a lot of time. So to cope with this limitation, what we did, we came out with a system called CrossChain. So this system, what it does, instead of looking at single files or at single URL to be processed, it uses statistics to do like a global detection of new threats. So how the system works, we keep a rolling window of 10 days. So we collect data from millions of machines in real time for 10 days. And at every night, we basically train two classifiers for doing real-time classification of new threats that are discovered in real time on new machine on a daily basis. So let's take an example to show how the system works easily. So suppose we want to classify F1. So F1 is a new file received on a new machine on a specific day. And this file is currently unknown to existing signature. So we don't know nothing about the file. So suppose this file gets downloaded from a machine, as you can see here, G1, that is known to have, that we mark as red, because in the past download other malicious file, like F3. So what happened is that since G1 is a machine that was in the past being compromised, we transfer this reputation of the machine G1 to the file F1. In addition, we also have another information here that comes from a URL from which this file has been downloaded. So the URL itself was known to be malicious, either the URL or the domain. So we also transfer this reputation from URL E1 to F1. So we use an algorithm called belief propagation to propagate the reputation of the adjacent nodes to the file F1 that in real time will get classified as malicious. So this example shows easily how basically we rely on the information of the adjacent nodes, which means we rely on the context in which a certain file has been downloaded. And this allows us to do real-time classification of new threats, like zero-day, target attacks, and it works is OS agnostic. It means that it works easily with a mobile, smartphone device, as well as IoT device, and so it's very easy to be extended to new technology, and it's fast, and as you can see, we have a good rating with true positive and also false positive from current testing and first implementation. So we're pretty happy about that, and I hope you will be happy to read our paper and the slides and all the video material available on our website. Thank you.